In this video, we will continue to explore simplifying expressions. In all of the ones that we're going to do in this section, we just have numbers. And so we should be able to get these number expressions with where we have adding and subtracting, multiplying, dividing, all of that. We should be able to do what it says and come up with a single answer. But it is very important to make sure that we all come up with the same answer. And in order to do that, we need to make sure that we evaluate and work on the things in these problems in the same order. In order to do that, we do have a common convention of what we follow, and it's called the order of operations. And what the order of operations does is it tells us if we have a math expression, what order should you do the things that you see in. Something that you may have heard of as a short way to remember the order is something called Pemdas. Pemdas tells us what order to do things in. The first thing we always need to do is do any parentheses in the problem. That's what the P is for. Parentheses are a way that we can override everything else to make sure that we do things in the order that we want to. E stands for exponents. Those are the next things that you should always do in any given problem. Now this is where people generally mess up. Next is multiplication and division. Multiplication and division are in the same level. So we do whichever multiplication or division comes first in the problem from left to right. That does not mean do all the multiply and then all the divide. It means multiplication or division, whichever one you see first. Addition and subtraction have a similar equal level. So when we get to the addition or subtraction part of the program, what we do is we add or subtract from left to right, whichever one we see first. All right, so let's do some problems and see how this order of operations works when we're evaluating things. When we look at this problem, the first thing that it says to do is what's in parentheses. So we need to do this 3 to the second power first. Notice when we take this to the second power, what's right in front of it is a 3, so we're going to do 3 times 3, and that's going to give me 9. So rewriting my expression, I have -5 times, instead of 3 squared, I'm going to write 9 plus 4. So that's the first piece that we have to do. What's inside the parentheses, and then we had those exponents that were there. Now at this point, notice I have a -5. If there's nothing written in between, it means multiply. So -5 times 9 and a plus 4. We always do multiplication before we do addition. So we're going to do the -5 times 9, which gives us a -45. And then add 4. Signs are different, so we subtract and we end up with -41 as the solution from here. Now most scientific calculators do know order of operations, so if you type expressions in exactly the way that you see them, parentheses and all, most of your scientific calculators will be very careful about evaluating that. I recommend doing both so you get some practice and make sure you get comfortable in knowing what to expect and how those things work. All right, moving on, let's try number 18. Here we have an expression with a fraction. We should probably write our final answer as a fraction, so it's in a similar form. But when we start with this one, we look at what's inside the parentheses, and it's 3/5. Well, there's not really a lot we can do with that. It's a simplified fraction. It's really just a single value. So we move on to exponents. When we look at what's in front of that third power, it's the 3/5. So what we're going to need to do first here is do 3/5 times 3/5 times 3/5. With a whole string of fractions, we can just multiply all the way across the top, all the way across the bottom, and I end up with 27 over 125 for this part of my expression. So what I have now is 27 over 125 minus 2. All right, well, if I want to subtract with fractions, remember I need a common denominator. 125 will be my common denominator between 125 and 1. If I times the bottom by 125, I have to times the top by 125, so I end up with 250 over 125. And then I can subtract the tops. So when I do 27 minus 250, and again you can think of that as 27 plus a -250, I'm going to end up with -223, and then you keep the denominator, -223 over 125. And that's a perfectly fine answer. You can leave it just like that. It's a simplified fraction. It is an improper fraction, but that's fine. All right, taking a look at number 19. This one has lots of fractions, and we have both subtraction and division. So it is important that in this case that we do the division first. So let's concentrate on this part. So I have to do 3/4 divided by 1/2. Remember, when we're dividing fractions, we don't really have a dividing fractions rule, so we multiply by the reciprocal. So I change the divide to times and then flip the 1/2 over to 2 over 1. And now we can multiply. I do see a factor that I can reduce a little bit here. 2 goes into both the top and the bottom, and I end up with 3/2 from doing the division. So that's the first piece that we want to do. Now I'm going to go through and rewrite my problem. Instead of this expression, I'm going to have 3/2. So now I need to do 7/8 minus the answer, so 7/8 minus 3/2. Again, I need a common denominator between 8 and 2. 8 will be a good common denominator. The first fraction already had an 8. For the second fraction, I'm going to have to multiply by 4. So I end up with 7/8 minus 12/8. Think of that as 7 plus -12, which will give us a -5, and keep the denominator the same. Make sure your fraction is reduced, and -5/8 would be our final solution for that one. In number 20, this is a slightly different one, and normally, and we have something a little bit strange here. Notice that we do have a fraction bar here, which does mean divide, but there is a little bit of kind of a hidden set of parentheses here, because you see how stretched out that fraction bar is? That means that we have to divide everything that's on the top by everything that's on the bottom. So if you ever see a big old fraction bar like that, the best thing to do is simplify everything on top and simplify everything on the bottom before you try to do anything else. All right, well, we do have to follow order of operations with the things that are on the top and the bottom. On the top, I have this exponents here. I have 6 squared, so we do exponents first. So that's going to give me a 9 minus 36 on the top. And I can actually do that 9 minus 36. Remember, think of it as 9 plus -36. And in this case, I would end up with a -27 on the top. On the bottom again, I have 12 plus 3 squared. We'll do the exponents first. That 3 squared is 9. So I have 12 plus 9. Keep the order the same, just replace whatever little piece you did. And then I can do 12 plus 9, which is 21. In this case, I'm almost finished, but not quite. I have -7 over 21. This is leaving it as a fraction is fine, but it's not a reduced fraction because 3 can go into both the top and the bottom. So divide the top and the bottom by 3, and we end up with -9 over 7, which is as simplified and reduced as you can get, and that would be your best solution. So again, anytime you're evaluating any expression, make sure that we follow the order of operations. Parentheses, then exponents, then multiply or divide left to right, then add or subtract left to right.